Good morning, students. Now, the next problem. In the circuit shown below, the angular frequency omega, at which current is in phase with voltage is dash radians. So, you have to find out omega. So, even though it is stated like this, it is a problem on resonance. It is a problem on resonance. So students study resonance under two headings: resonance in series RLC circuit, resonance in parallel circuits. So this is resonance in parallel circuit. So here there are three branches: inductor branch, resistor branch, capacitor branch. And when the circuit is in resonance, so current and voltage are going to be in phase. That is why current is written as I naught sine omega t. So generally, whether it is series resonance or parallel resonance, what happens when the reactive part of the impedance becomes zero? Resonance will occur. As you know that impedance is of two parts: real part and imaginary part. So the imaginary part has to become zero. Then only the impedance in the circuit becomes purely resistance. That is what resonance. Now in this circuit, in this parallel circuit, now I will make use of one point. Admittances can be added. We can't add directly impedances. In series circuit we can add impedances, but in parallel circuits we can directly add admittances. What is admittance? Admittance is reciprocal of impedance. Now I advise students not to substitute the values in the beginning itself. First you call this as L, call this as R, call this as S. Otherwise you will get confused. That is why call them as L, R and C respectively. So XL becomes equal to L omega. Let omega be the resonance frequency. XL is equal to L omega. That is Z. Reciprocal of that, as you know that XL is represented as JL omega. Reciprocal of that is 1 by JL omega. Capacitor XC. XC is minus J by omega C. Minus J by omega C. Now admittance becomes reciprocal, omega C by minus J. Then resistance R. Resistance are R. But in the case of resistance, admittance is 1 by R. Mho. It is in mho. Now multiply and divide. Multiply numerator and denominator by J. So J by J squared L omega. Here I will multiply numerator and denominator by J. J omega C by J square minus J square. And I don't touch YR. YR let it be as it is. Now if you simplify, J square becomes minus 1. Therefore this is minus J by L omega. Whereas this J squared is minus omega, minus 1, minus of minus plus, therefore it is J omega C. J omega C. And YR remains as it is. Now what is net admittance? Net admittance equals 1 by minus J by L omega minus J by L omega. Next plus J omega C plus 1 by R equals 1 by R plus J into omega C minus 1 by L omega. Now this is real part, this is imaginary part. Imaginary part is made equal to 0. Therefore omega C minus 1 by L omega equals 0. That implies omega C is equal to 1 by L omega, or omega squared is equal to 1 by CL, or omega is equal to 1 by root CL. Omega is equal to 1 by root CL. That is 1 over root of C. 500 nanofarads. 500 nanofarads means minus 9 factor. Then L is 5 millihenry. 5 millihenry. Now resistance has nothing to do with resonance. Only it can alter the magnitude of the current. That's all. Equals 1 over square root of, simplify, 25 into 10 to the power of minus 10. That is equal to 1 over root 25 into 10 to the power of minus 10 to the power of half. That is 1 by root 25 into 10 to the power of minus 5 equal to 10 to the power of 5 by root 25. That is 100 by root 25 kilo radians per second. Kilo radians per second. That is 100 by 5. That is 20 kilo radians per second. Kilo radians per second. So this is how you have to work out this problem.